Hello everyone, I'm Dr. Vivek Saxena. In this lecture, we will talk about the frequently asked question in the university examination. As you can see, there are two types of question that have been asked in the university examination. First type of question is 2 marks question, and the second type of question is long answer type question. In the short answer type question, mainly frequently asked questions are: first question is, what are the respective values of internal resistances of ideal voltage source and current source? And is it possible to convert each other? The answer of this question, you have to write there. First one is the internal resistance of ideal voltage source is 0. And the internal resistance of ideal current source is infinite. And is it possible to convert into each other? No, it is not possible to convert ideal sources into each other. It is possible in case of practical sources. Practical voltage source can be converted into practical voltage source, and practical voltage source can be converted into practical current source. This one is our first question that have been frequently asked in the university examination. After that, question number 2, draw the characteristics of ideal and practical sources like voltage source and current source, and also explain their properties. It may be asked in terms of complete question have been asked in short answer type question, or it may be bifurcated in terms of that you have to draw and draw the symbol of ideal and practical source and draw the characteristic of ideal and practical sources, and explain the characteristics of ideal and practical voltage sources, and explain the characteristic of ideal and practical voltage sources. Then you can write such type of you can write such type of the answer of such type of question is that for ideal voltage source, this one is the symbol of ideal voltage source, as you can see here, and this one is the characteristic of ideal voltage source. In this characteristic, you can see here that the output voltage of ideal voltage source is always constant at any value of output current. So this one is the symbol and this one is the characteristic. You can write, if you have been asked that explain the characteristic of draw the characteristic of ideal voltage source. This one is the ideal current source. The characteristic of ideal current source that the output current remains constant at any value of output voltage. And this one is the symbol of ideal current source. The value of internal resistance of ideal current source is infinite, and the value of internal resistance of ideal voltage source is 0. Now, the next question that have been asked many times in the university examination, that is your explain the following with example, or differentiate the following, any one part or any two part of this question. First one is linear and nonlinear elements, that explain the following with example, or you can, and it has been asked that differentiate between linear and nonlinear elements with example. Similarly, active and passive elements and unilateral bilateral elements. As we have already covered such type of fundamentals in our lecture number 4, but I am revising here that the linear elements are those elements which have linear VI characteristics, and nonlinear elements are those elements which have nonlinear VI characteristics. The example of linear elements are resistor, inductor, and capacitor, and the example of nonlinear elements are diode and transistor. Our next part is active and passive elements. Active elements are those elements which enhance the energy level of the circuit. Example is transistor, current source, and voltage source. And passive elements are those elements which do not have the capability to enhance the energy level of the circuit. Now, if we talk about the examples of these passive elements, this one is resistor, inductor, and capacitor. Now, our next types of elements are unilateral and bilateral elements. It may be asked It may be asked that differentiate the unilateral and bilateral elements. Then you can write there that the unilateral elements are those elements which have different VI characteristic with respect to their terminals. If we are changing the terminals of such type of element, then the characteristic would be changed. The example of unilateral elements are diode and transistor, and bilateral elements are those elements which have same VI characteristics with respect to their terminals. If we are changing the terminals of bilateral elements, then the VI characteristic will not be changed. These are the bilateral elements. Our next frequently asked question, that the name of circuit laws on which mesh method and nodal method are respectively based. As we have already covered in our lecture number 3 and 4, then then the mesh method is based on KVL and the nodal method is based on KCL. KVL is our Kirchhoff's voltage law and KCL is Kirchhoff's current law. KVL states that in any mesh or loop, the algebraic sum of all the voltages is equal to 0. And KCL states that at any node or junction, the algebraic sum of all currents is equal to 0. After that, we will talk about the long answer type question. In university examination, after short answer type question, there are long answer type of question. In the long answer type of question, there would be numerical on the basis of mesh or nodal analysis method. For showing the demo, I have taken the numericals that have been asked in odd SEM and even SEM university examination. In the even SEM university examination, as you can see, the first question is using nodal analysis, find the branch currents in the circuit. In this circuit, we have to use the nodal analysis method to find the voltage, to find the current of each branch of this circuit. By using nodal analysis method, you can refer my lecture number 4 to solve this circuit with the help of nodal analysis method. By nodal analysis method, firstly we have to find the number of nodes. There are three nodes, 1, 2, and 3. 3 and 4 nodes are common. It means total 3 nodes are there. After that, we will assume the zero voltage. Here we can assume zero voltage in the bottom of 3 ohm resistance or 12 ohm resistance. And after that, remaining 2 nodes, there is one node, we already know the voltage of this node. This one would be, if we are assuming 0 voltage at the bottom of 3 ohm, then the top of the 3 ohm resistance would be 6 volt. It means there is only one remaining node is there. We will assume here a V voltage here, and after that, we will assume the branch currents which are associated with the node A, and after that we will apply KCL in this circuit, and then we can find the voltage at this node. After finding the voltage at this node, we will able to find the current in any or each branch of this circuit. This one is next numerical that have been asked in even semester 2023-24, that find current in 4 ohm resistance in the figure using mesh analysis method. And for finding the current in 4 ohm resistance, you can refer my lecture number 3, where we have already talked about the how to apply the mesh analysis method to solve a circuit or find the current or voltage in any branch of the circuit of the in any branch of the circuit of in any branch or element of the circuit. For finding the value of current in 4 ohm resistance, firstly, we have to assume the number of mesh. Here, 1, 2, and 3. 3 meshes are there. We already know the value of third mesh, that would be 2 ampere. After that, remaining 2 meshes are there. We will assume the current in first mesh and second mesh. After applying the KVL for first mesh and second mesh, we will find the value of mesh currents. After that, the resultant current in 4 ohm resistance would be equal to the current of first mesh minus current of second mesh. This one would be the final result. Next question is that have been already that have been asked in E1 semester 2023-24 that by using nodal analysis method, we have to find the value of I. I is the current in 4 ohm resistance. For finding the current in 4 ohm resistance, we have to apply the nodal analysis method. For applying nodal analysis method, again, I am saying that you have to find the nodes. Nodes are in this circuit, there are 1, 2, 3, 4, 4 nodes are there. Third and fourth nodes are common. It means there are only 3 nodes. Firstly, we are assuming the zero voltage node. After that, the remaining node we have to assume unknown voltage. After that, we will apply KCL, and after applying the KCL, we will find the value of node voltages. After finding the node voltage, then we will able to find the current in 4 ohm resistance by using nodal analysis method. Next question, this one have been asked in odd semester 2023-24. In this question, you can see here, calculate the current across 20 ohm resistance using nodal analysis in the following circuit. Calculate the current in 20 ohm resistance using nodal analysis method. Again, we have to find the number of nodes in this circuit. In this particular circuit, for solving such type of circuit, you can refer my lecture number 4, where we have already talked about the nodal analysis method, how to solve the how to solve the circuit by using nodal analysis method. In this circuit, we can apply the nodal analysis method. Firstly, we have to find the number of nodes. After that, we will assume the zero voltage and then assign the unknown voltage at the remaining nodes. Here, two unknown nodes are there where we have to apply the KVL. After applying the KVL, we will able to find the voltage of these nodes. And after finding the voltage of these nodes, we can find the value of current in 20 ohm resistance. Next question, question number 9. As you can see here, this one has been asked in odd semester 2023-24. Then calculate the current across 6 ohm resistance in the following circuit using mesh analysis. First and second is nodal analysis method. You can, for applying the mesh analysis method, you can refer my lecture number 3. And for applying nodal analysis method, you can refer my lecture number 4. In this circuit, if we are using the mesh analysis method, there are two meshes are there. Firstly, we have to assume the mesh-wise current. After that, we will apply the KVL. After applying the KVL, we will find the value of I1 and I2. I1, if we are assuming the I1 current in first mesh and I2 current in second mesh. After that, we can find the value of current in 6 ohm resistance. That would be I1 minus I2. If we are applying the nodal analysis method, there are two nodes, first and second. One node we have to assume zero voltage. It means there is only one equation in if we are applying the nodal analysis method. After assuming the unknown voltage at assuming the voltage at unknown voltage level of this node, then we have to apply the KCL. After applying the KCL, we will able to find the voltage level of this 6 ohm resistance, and at the bottom of 6 ohm resistance we already assuming the zero voltage. It means if in the voltage the top of this 6 ohm resistance is V, then the current in the 6 ohm resistance would be V minus 0 divided by 6. It would be the final current of 6 ohm resistance. These are the various frequently asked questions that we have been discussed in this lecture. As you can see, there are few short answer type questions that have been asked repeatedly in the university examination, and in the long answer type question that there are two types of question may be there, that you have to find the voltage or current in any type of circuit by using mesh analysis method or nodal analysis method. These are the references. Thank you for watching this video.